Hi, this is Chris with Sanderson Test Prep, and we are now taking a look at Section 3 of SAT Practice Test 2. So here we'll take a look at these first few math problems, and we'll start with question 1. Now again, keep in mind in the math, the difficulty level does go easy to hard. So for some of these early questions, we'll move through pretty quickly. And if you do have additional questions, feel free to comment or contact us if you want to go over those in greater depth. You can also rewatch any portion of these videos. But for the first question, we have 5x plus 6 equals 10. And in order to solve, we're going to subtract 6 from both sides. So that will give us 5x equals 4. We can divide both sides by 5, which will give us x equals 4 fifths. And then we can plug that in to x in the expression 10x plus 3. So that would be 10 times 4 fifths. When multiplying fractions, you just multiply straight across. So you multiply your numerators. That would be 40 over 5, which is 8. And we will be left with 8 plus 3, which is 11, for our answer to question 1. Let's go ahead and keep moving. We're going to move on to question 2. Here we have a system of equations. So x plus y equals 0 and 3x minus 2y equals 10. Now when you have a system of equations, you can solve via elimination, which is where you try to multiply by a coefficient to cancel out one of the variables. And that's a really good strategy, which is probably going to be most applicable on a more complex question. But again, using the question difficulty to our advantage. We're on question 2. So a lot of times, if you have answer choices that provide possible solutions, you can use an equation to test some of those out. And you want to try to use the easiest equation. In this case, x plus y equals 0 is probably the easier of these two equations to work with. So let's try that out and see if any of these answer choices would give us 0 when we add those together. So 3 and negative 2 won't give us 0. 2 and negative 2 works. Negative 2 and positive 2 works. And then negative 2 and negative 2 would be negative 4. So that doesn't work. So hopefully we can use an easy equation to get a couple quick eliminations. And now we just need to test out an answer choice on the second equation. This one's a little bit more complex, but let's test out B, because the correct answer has to work for both. So if we plug in a 2 for x, remembering that every coordinate that you see is written x comma y, so that would be 3 times 2 minus 2 times negative 2, and we have to be very careful with signs here, equals 10. And let's simplify. 3 times 2 is 6. A negative 2 times a negative 2 is a positive 4. And that gives us 6 plus 4 equals 10, which does work, and lets us know that we can, in fact, confirm answer choice B is our correct answer here. Let's go ahead and move on to question number 3. So this one's a little bit of a longer word problem. A landscaping company estimates the price of a job in dollars using the expression 60 plus 12 NH, where N is the number of landscapers who will be working, and H is the total number of hours the job will take using N landscapers. Which of the following is the best interpretation of the number 12 in the expression? And we see our answer choices below. So one thing I'd like to point out here is that we have 12 as a coefficient on this expression. Let me move that over a little bit. But here we have 12 as a coefficient on this expression, 12NH, which means that 12 is being multiplied by both the number of landscapers and H, which is the total number of hours the job will take. So that means when we're asked what 12 is going to represent, it has to represent a value that will be impacted by both the number of landscapers and the number of hours. So let's take a look. Answer choice A says the company charges $12 per hour for each landscaper. So here we see hours and landscapers included as factors that are going to be impacted by that number 12. And that seems to match what we see in the expression above, but let's take a look at the other answer choices. B says a minimum of 12 landscapers. So talks about landscapers, but it doesn't mention anything about the number of hours. And remember, this expression covers both number of landscapers and number of hours. We need to see both of those factors included in a correct answer choice. So we can say no thank you to answer choice B. Now for C, it says the price of every job increases by $12 every hour. So again, here, we're only looking at one of those factors. We're looking just at hours. But because 12 is a coefficient on both the n and the h variables, that means that both of those components, number of landscapers and total number of hours, would have to be included in our answer choice. Now for D, it says each landscaper works 12 hours per day. So they mention the word landscaper and they mention the word hours. So we might think, okay, we can keep this one on the table. And let's take a look then at these two. One of them is showing us a dollar value. And one of them is just stating a fact about the number of hours that the landscapers work. So let's look back at our expression originally, and it says that this entire expression is supposed to estimate the price of a job in dollars. So here that in dollars part is key because that's our last clue that lets us know we have to have a dollar component to our correct answer here, which would be answer choice A. So although this is a very long word problem, we don't have to actually interpret the exact meaning from scratch, but we can use the answer choices to our advantage to recognize which answer choice includes these two components and represents a dollar value. And as long as we can use the guidance that they give us in the word problem itself as to what each variable represents, we can answer a question like that relatively quickly. Now let's take a look at question 4. Another one where we have a tiny bit of a shortcut. So here it says which of the following is equivalent to the expression shown above. So we have options. Whenever we're given a lengthy polynomial like this, we can try to factor that out, or we can take our answer choices and try to distribute or FOIL those answer choices to see which one would match that expression above. Now here is a little tip. The first term in each parentheses will be carried to that corresponding exponent and end up as the first term or the leading term in your final polynomial. So before we try to work everything out and come up with these extremely long and complex looking statements, let's work just with the first term of each. If we need to go on to the second or third or fourth term and we need to distribute it out completely, then we can. But let's see what happens, because again, we're on question 4 out of 15, which in terms of difficulty level, right, if this is 4 out of 15, we're still in the first part of this multiple choice section, which means these questions should be a little bit more manageable. We're in the early goings. So let's try just the first term of each. 3a squared, if we square that, 3 squared is 9. A squared to the second power would be a to the fourth. So far, so good. That matches that first term. Let's see how we do with these others. What is 3a to the fourth? Well, 3 to the fourth is 81. And then a to the fourth, just a to the fourth. We can already tell for answer choice B that we can eliminate it because it doesn't match that first term of 9a to the fourth that we have in our equivalent expression. Let's try 9a squared to the second power. Square each term. 9 to the second is 81. A squared to the second power would be a to the fourth. Also possible for us to eliminate C. And for D, 9a to the fourth, we have 9 to the fourth power. And we could take the time to do the math on it if we want, but keep in mind, and for every question, you want to look at the math associated with it and keep in mind whether or not you're in a calculator section. This is a non-calculator section. So 9 to the fourth, you could do 9 squared is 81, and then times 9 again, which is 729, and then times 9 again, that math starts to get very complicated, but you can already tell that it's not going to be equal to 9a to the fourth. So you can probably eliminate it without having to do the math. If you did the math and you wrote it out, you would get 6,561 a to the fourth for that first term, which we can tell does not match the first term here. So if we focus just on the first term, that's enough in this question for us to come up with the correct answer choice without having to completely distribute or FOIL out every single answer choice. And anytime we're given an opportunity to save a little bit of time and maybe decrease the complexity of calculations that we have to do, especially in a no calculator section, then that's always going to be a win SAT-wise. Stay tuned for our next video, and we'll take a look at the rest of the questions in this math section.